Hello dear students, in this session we will see what happens if we apply alternating voltage to a pure inductor. Pure inductor means in that circuit there should be only inductor, there shouldn't be any resistance, there shouldn't be any capacitance and all. Okay, so here we have considered a pure inductive circuit. There is an inductor and we have applied a alternating source. Now here what happens, since when the variable current flows through this inductor also induces some current. Hence there are two voltage sources. One is this voltage, applied alternating voltage. Another is induced EMF. So therefore, according to KVL, according to Kirchhoff's voltage law, we can write the sum of all the change in potentials throughout the loop is equal to 0. Or we can write V plus E is equal to 0, because there are no resistances in the circuit. Okay, now what is V? Applied alternating voltage. Applied alternating voltage is written as V is equal to Vm sin omega t. Applied alternating voltage is V is equal to Vm sin omega t. And what is the equation for induced EMF? Since it is a coil, okay, I'll write somewhere here. Okay, induced EMF E is equal to minus d phi by dt. Minus d phi by dt. Now what is phi? Phi is equal to L into I. Correct na? L stands for self-inductance. So what happens? This is equal to minus d by dt of L into I. What is L? L is a constant. It can be written outside. So therefore, in the place of E, induced EMF, I'll write minus L into di by dt. Minus L into di by dt. That is equal to 0. Okay. Now what I can do, I can take it to the RHS, or I can write like this: L into di by dt. L into di by dt is equal to Vm sin omega t. Vm sin omega t. Now here, what is my aim? Okay, my aim is, what is the equation for applied alternating voltage? Applied alternating voltage is given by V is equal to Vm sin omega t. V is equal to Vm sin omega t is the applied alternating voltage. Now what I have to do, I have to write an equation for alternating current. Then I should compare those two equations. So that is my aim. So I should write an equation for I. But, so here I have got an equation for di. Using this equation, I can write an equation for di. Then if I differentiate that di, I'll get an equation for I. So what happens? If I write an equation for di from this equation, di equal to Vm divided by L into sin omega t dt. Okay. Di equal to Vm divided by L into sin omega t dt. Okay. Now I'll integrate this equation. On integrating. Okay. On integrating. What is integration of di? Integration of di is I. Correct? I is equal to integration of this. Vm and L are constants. Vm divided by L into integration of sin omega t. What is integration of sin omega t? So sin omega t into dt. I have missed this dt. Hope you can understand. Di is equal to Vm divided by L into sin omega t into dt. I have missed that dt. Okay, I'll write it. Integration of sin omega t with respect to t. Correct. What is integration of sin omega t? Minus cos omega t divided by omega. Correct. Now what is integration of sin ax? Minus cos ax divided by a. Correct. Now so therefore I can write this as I is equal to Vm divided by L into integration of sin omega t is minus cos omega t divided by omega. Or I can write this equation as I is equal to Vm divided by omega L into minus cos omega t. I can write minus cos omega t as sin omega t minus pi by 2. I is equal to Vm divided by omega L into, I can write this as minus cos omega t as sin omega t minus pi by 2. Why? What is sin 90 minus theta? Sin 90 minus theta equal to cos theta. Correct now? Or sin pi by 2 minus omega t, 90 minus theta. Correct now? Pi by 2 minus omega t is cos omega t. Therefore, what is sin omega t minus pi by 2? Sin omega t minus pi by 2 will be minus cos omega t. Hope you can understand. Okay. So what happens? Sin omega t minus pi by 2. Or I can write this equation as I is equal to Im into sin omega t minus pi by 2. Sin omega t minus pi by 2. So this is my equation number 2. Okay, equation number 1. What is the equation for applied voltage? V is equal to Vm sin omega t. What is the phase of that? Phase of that is pi by omega t. What is the phase of current? Phase of current is omega t minus pi by 2. So therefore, what is phase difference? Phase difference is omega t is here and omega t is here. Correct now? So phase difference is pi by 2. Now, what is the equation for Im, or if I write a phasor diagram? Okay, how to write a phasor diagram? I'll write here once. Equation for V is equal to Vm sin omega t. Okay, I is equal to Im sin omega t minus pi by 2. Sin omega t minus pi by 2. So therefore, voltage leads current by pi by 2. What is the conclusion? Voltage leads current by pi by 2, because voltage is omega t, current is omega t minus pi by 2. Okay. Now if I write the phasor diagram, okay, if I write the phasor diagram, what is the phasor of voltage? Phasor of voltage, okay, makes an angle omega t with the time axis. Correct now? What is the phase of voltage? Phase of voltage is omega t. What is the phase of current? Omega t minus pi by 2. So this is omega t minus pi by 2. Omega t minus pi by 2. So this is the phasor of current. Okay. So this is the phasor diagram of voltage and current in the case of pure inductive circuit. If you want to represent voltage or current sinusoidally using a graph, then if this is the variation of voltage, okay, if that is the variation of voltage, variation of current would be, see, this is the variation of voltage, okay, variation of current would look like this. Why? See, voltage has become 0 here. Current will become 0 after 90 degree. See, this is 0 degree. This is pi by 2. This is pi. Correct now? Voltage becomes maximum at pi by 2. Current becomes maximum at pi after 90 degree. So this is the variation of current. So this is how you represent voltage and current in the case of in terms of phasor diagram or in sinusoidal variations. Okay. Now if you look at this equation, I is equal to Im sin omega t. What is the value of Im? What is the value of Im? Value of Im is equal to Vm divided by omega L. Okay, Im is equal to Vm divided by omega L. So we know the equation for current in the case of pure resistive circuit. I is equal to Vm divided by R. Correct now? Now in the place of resistance, there is a term called omega L. So therefore, this omega L is analogous to resistance. Resistance offered by the resistor or opposition offered by the resistor, we call it as resistance. Opposition offered by the inductor. So therefore, this is opposition offered by the inductor. We represent this as XL and we call it as inductive reactance. XL is called inductive reactance. What is the equation for XL? XL is equal to omega L. What is omega? Omega is 2 pi f into L. Equation for inductive reactance is 2 pi f into L. Now we are using here alternating current. What if the current is DC? For direct current, what is the frequency? What is the frequency for direct current? since the direction of current doesn't change, frequency for direct current is 0. So therefore for DC, inductive reactance is 0 since the frequency is 0 for DC. So therefore if you observe in current electricity chapter, we are not using inductor, because in current electricity chapter we were using cell, correct? Now we were using cell and that was producing direct current. For direct current frequency is 0, inductive reactance is 0. Even if you use an inductor, it will not offer any opposition to the current and it just behaves like a wire. Okay, so we have studied what happens if alternating voltage is applied to a pure inductive circuit. Okay, so if you apply to a pure inductive circuit, okay, say if V is equal to Vm sin omega t is the applied alternating voltage, the current, the equation of current will be I is equal to Im sin omega t minus pi by 2. What does it mean? In pure inductive circuit, voltage leads current by pi by 2, and this is the phasor diagram. Okay, and equation for inductive reactance is omega L. In the case of DC, frequency is 0, inductive reactance is 0. So that is why we use inductor in the case of AC circuits. In DC circuits, we are not using inductor because its inductive reactance is 0. That means opposition is 0. Even if you use an inductor in DC circuits, it behaves just like a wire. Hope you understood this derivation. Thank you very much.